All right, here's page 131, number 114. We're going to do an example of not just determining the atomic mass, but finding out an unknown isotope. So the question or the problem that you're given is indium, which is letter IN, that is the symbol. Indium has two naturally occurring isotopes, and the atomic mass, so this is the atomic mass that is given to you, is 114.818 AMU. Now, we're given one isotope. So we know that there's two. We're given one. Indium 113, okay, has a mass of 112.904 AMU and an abundance of 4.3%. Now, the question that we're trying to answer is, what is the other isotope? And what is the abundance of that other isotope? There's several steps that we have to take in this situation. So we know that since there are only two isotopes, we were told that in the problem, two isotopes, meaning they have to equal 100% of all of the indium. So we can answer this question right away. If one of the isotopes is 4.3%, then all we have to do is 100 minus 4.3, and we should get 95.7%. So indium, and this is our mystery isotope, we don't know its mass, but we do know that it's 95.7%. Okay. Now we're going to have to work in reverse. First thing we do is, again, move that decimal over so that we get rid of our percentages for here too. Now we have 0.043 and 0.957. All right, and again, we don't have, this is X. We don't have that yet. So we are going to do 112.904 times this abundance, times 0.043. Let me get my calculator so we can do that. 112.904 times 0.043, and we get 4.854, and I'll round right there, AMUs. Okay, and again, we have no idea what this one's going to be, but we do know that the total from the information given is 114.818 AMUs. So in this case, we can determine what this question mark is simply by taking this number, this atomic mass, and subtracting the mass, or really the mass that we got for this isotope. So 114 minus 4.8549 is not something I'm going to do in my head. 0.818 minus 4.8549, and we get 109.9631. So that's this right here. So now we know that, I'm going to move this up a little bit. Now we know that this mystery isotope, this indium, we don't know, has a mass of X times the abundance, which is going to be 0.957, has to equal 109.9631 AMU. So how do we solve for X? And hopefully you are familiar enough and comfortable enough with some algebra to be able to do this. You're going to divide by 0.957 on both sides. 0.957. So here this cancels out, and you're going to have X equals, back to our calculator, 109.9631 divided by 0.957. And you get 114.90, we'll say 4. Okay, so that is the mass that would go right here. So now we know, we don't have x here, now we know it's 114.904 AMU. Remember that when we're looking at the type or the isotope and we're looking at the mass, they're very, very close. But this mass number has to be a whole number because we're just looking at the number of protons plus the number of neutrons. Remember that. Mass number is number of protons plus number of neutrons. Okay, so it has to be a whole number. It's not the mass, which can be off a little bit because the mass is off a little bit because the protons and the neutrons don't have a mass of exactly 1 AMU. There's a little bit of wiggle room there. So if we're looking at 115.904, we would have to round that to the nearest whole number. And in this case, I would round it to 115. And indeed, the other isotope of indium is isotope number 115. Now, again, you can check your work by essentially doing what we were doing previously, where you look at these two isotopes and their abundances, and hopefully you would end up with that atomic mass. It's something that you can try on your own and just check. You already have the answer there in front of you. Feel free to try any of the practice problems in the textbook. There are many of them. Okay, and there are many more practice problems on the internet. All you would have to do is search determining atomic mass. Keep in mind that you do need to be able to do this for the upcoming test.